So tag, we have arrived at the top of the castle here. This is sometimes called branding. I think I usually see it called branding. Tagging is a good word too. So there's a lot. I just want to warn everyone. This is a tough one. The solution we're going to look at is 550 lines. So. So it says, despite the structural typing system in TypeScript, and this is another one from UID 11. So they said, it's sometimes convenient to mark some types with tags, and so that these tags do not interfere with the ability to assign values of these types to each other. So we're kind of like undoing the fact that TypeScript has a structural type system. So so it says, for example, you can check that some values pass through the calls of required functions and in the correct order. So it gives a bunch of examples here. I would be reading for like quite a long time to read through all of these. I'm gonna, instead of reading them here, let's just take the challenge and we'll kind of like say a little prayer for our mental health and then dig in piece by piece through all of the helpers, because this one has a few helper types. Okay. How you doing, Andrew?
I'm all right. Well, ask me again in 15 minutes.
Okay. All right. So we start with, I think, pretty much all of these with the same or close to the same null. Okay, yeah, sometimes we're tagging null or undefined or literals, but very often we're going to be using this foo type here we have at the, or I type here, whatever, that we have at the top, I think, or something. So if we have I, and this is showing assignability, otherwise we would get an error. So we have I is just a regular interface with foo and string. This is the last thing that will make sense in this challenge, I bet. So we can tag I with A, or we can tag I with B. So let's look at what tag is. Let's go down here. So this is the solution. This is this is the solution by the author as well. So I hoped that by picking, I looked through a bunch of them. Just this one goes, we're at line, 473 to look at the solution. So then there are lots of helpers. So I figured, like, if we can just look at one, let's look at the one from the author. Even it is a little more complicated, but it's okay. So we have V is the input type that he named it. I don't know why, but that's what it is. And then we're using the equality check to see if V is equal to null. So if V is null, then we return null. If V is undefined, we return undefined. Okay, great. Otherwise, we are making an intersection. This thing here, key, let's go find it. Key is a unique symbol. So we're going to be using key a bunch. So just keep that in the back of your noggin for a second. Let's go back down to tag. So we're saying type of key extends key of V. Any idea what that does?
So we're checking to see if the key of V is our unique symbol.
Yes. I think meaning like, is it already tagged?
Right. Okay. Yep. So this would be just like, right. Is any of the keys of V already our symbol?
Right.
Yeah. Which means we've already tagged this object. Cool.
So, in this case, and then like, if so, from V, we can remove those things. Otherwise, we return V. Then, so we're kind of like refreshing it or something. Otherwise, we return a read-only object, the property of which is that unique symbol. It's optional. There's this part. Somebody asked in the comments on like online, what does that part do? I stared at this for a long time, and I genuinely do not know what this part does. The tests do fail if you take it out. There's some special sauce in here. I mean, I think it may be arbitrary. Yeah, like it doesn't matter. Oops, we could put anything in here. It doesn't really matter. I don't know why. We do need something here though. It's like a unique value that's unique to this line. Mysteries from above. Okay, so but this thing, the value. So this now we're into the value.
Essentially, that is the yeah, exactly. It's the value of the object. I think like it's because we've got a key. Yeah, it's the value, and then we intersect it with whatever our I guess this next piece is this the tag?
I think so. So tags key was taken from above. We have get tags and get tags key. So let's like pause and go look at those. So get tags. Okay. We have up here, it gives us some like special types for this. So get tags of null is an empty array. Get tags of any is an empty tuple rather. We have this tagging structure here, which is confusing because now they're all of a sudden recursive, but oh well. So if we get tags of a string can have stuff added to it. We're going to get, if we pass in foo, we'll get back an array. So this gives us a tuple rather of foo. We're going to get back the tags of something that was tagged twice, and we'll get back the kind of nesting of that thing. So, you know, if we have an object, we tag it with foo, then we tag it again with bar, then we tag it again with baz. We're going to get back foo bar baz in that order. So this one does a hybrid approach. It uses some things in temporary storage like variables and some things not. So we have two things here. Tags are undefined and tags or never. Of course, to understand these, we have to go to this get string props, but just looking quickly, we're breaking distributivity with this syntax to see if the union, which we could get in from here, T, extends tagged. So what is tagged? Tagged is an interface that has that key that we saw before. It doesn't care what the values are, so we say unknown. So we're just seeing if it matches that interface. If it does, then we're going to grab the value. Otherwise, we're going to return undefined. And that will become useful in the next part because we're going to get string keys. We'll talk about that. But first of all, we're going to we're going to exclude undefined from here. So we could be passing never, which is what would happen. That's what the path that exclude returns if nothing matches. Are you with me so far? I
think so. Yeah. Okay. The pieces are starting to come together here.
Okay. So then we have get string keys, which is itself an exclude block. So we create an object and then immediately index it. So we're kind of getting, and that because what we're doing here is actually sort of filtering. We're intersecting with string, meaning we're going to get the string keys. What's not a string key? The symbol. So we're kind of taking out now the symbol. We're just getting the string keys. Okay, so that's tags are undefined.
It looks like we're also filtering out that zero key, right? Just based on the comment on like line 415 there.
So maybe that's why it doesn't work. Okay, that's an interesting point. So if we push in here, if we put something like that, all the tests fail.
Yeah, something that does match as a string, it should fail. But a number won't fail because of our string intersection.
Yeah, and the value here doesn't matter at all. It could be anything. Okay. All right. Andrew, you're really you're starting to make sense of this for me. Thank you. I don't know
about that, but
so we don't actually use tags are undefined later. We just use it here, and tags are never. So you can see why the person chose, because otherwise you would have to like do that. Like you'd have to write the same thing 6 times, literally.
Yep.
So we do it here. So we're seeing if tags are undefined equals never. I don't know if this is actually a valid way to do that. A never check, but anyway, it should work, I suppose, because the tests pass. So if it extends true, so get tags key. So this, again, we didn't talk about what this returns. If you pass in null, it returns an empty string. If you pass in a tag type, it will return, oh, look at that, 0. So
it's got like the position of the key, because then in the next one you've got foo and bar, and it's got 0 foo 1 bar.
Interesting. So I wonder if somewhere we're incrementing that number. So it all works because it is some number. So let's put this back to 0. Oh, interesting. So then we're slicing at that. Interesting. Okay, where do we go here? Sorry. I got lost. Oh no. Get tags
420,
key.
yeah.
Okay, so I'm back. Okay. It's like being in IKEA. That's what this one is like. You get turned around, you don't know where the exit is, and it's just like you can't, no directionality to it. Okay.
We're never leaving this type challenge.
So, all right. So we're seeing if tags or keys equal to string, which would happen if it wasn't any particular string. We would hope that it will be. So yeah, if we don't have the value, this could happen, I suppose, with an indexed type. And then at the end, we have our base case. We return just tags key or never. So yes. Okay, so I kind of get it. The recursion, this is something I didn't understand, but it's making more sense now. So the recursion, the part where we build up the key is, well, where? Where would tag? Oh, because we're unwrapping it. Okay.
Yeah, it's not clear to me where we like concatenate that string to get 0 foo 1 bar.
Yeah, me neither. Let's see if we can find it. So, all right. That's that portion of things. That's get tags. Let's look at get tags key. Oh, we were looking at get tags key. Okay, wait a second. So maybe that's it. It must happen sooner. It must happen at get the level of.
I think it's happening on line 490. Is that it? There's some string concatenation going on there.
Yep. Okay, tags key. That's this particular one, and then we have the length of the. Oh, okay. So we get all the tags, and we grab their length. We put the number in there, and then we get the actual string, which is T in this case.
Yeah.
And then, yeah, it's built up like this. Okay.
Cool. So we get our tuple out of there.
Great. Let's look at get tags, because I did them in the wrong order, I think. Get tags looks very similar to get tags key. We have this same structure, like all this stuff is the same. Get string props is different. So, get string props and I think it was get string keys before is the properties and keys is almost the same, except at this position we're grabbing, see that TK is what we have for the actual properties.
Instead of just the K.
Yeah, exactly. So that probably could have been combined in some way, but I don't think that the goal of this approach was to split things up, I think, like in general. So we see these are helpful little hints above. So if we pass in, our object, then we get back the value. So in this case, we get back the keys. So, okay. So that's get string props. All right. So get tags, get string props. Now we have, that is tag. So that's like step 1. Okay. I think that we probably hit most of how it works. So like step 1 is tagging a thing. So let's read what they say. So if we pass in number, we get back number with the tagged with foo. If we pass in an object, we get back that object with the tag foo. And if we tag something twice, we get v with a tuple of the tags foo and bar.
Makes sense.
Okay. So zooming up to the top, let's go back up and take a look. So we have these things. They are assignable to each other. We can tag something twice. That's what this shows. We can, next thing, we can untag. So we haven't actually hit any tests yet, but the tests are here. We're getting there, I suppose. So let's look at untag. I think this one is the first moment that made some sense to me. I mean,
yeah, we're just pulling off that symbol key if it's there.
Yeah, exactly. So we're going through that tag structure. The tagging happens at a high level, so we don't need to, there's no nesting that goes on. We just can grab that key thing that we had previously stored and remove it. Okay, so that's untag, and that gets us to the back to the place. So like x6 and x7 are assignable to each other, and we see that they are. Okay. So let's talk about now, you can tag other things. You can tag string. We saw that you can tag number. It creates an object, like if we hover over y1, for example, we see that what we get back is pretty complicated, but I think we saw most of it. I don't think you can see this on your screen, Andrew, unless you hover too, but like we have string.
Yep, I can see that.
Intersected with an object or a mapped structure interface, inside of that, there's just one property. It's a read only, and it has that key thing that we previously stored. The value of it is a union. The first element of the union is an object that has that 0 true thing that we saw, intersected with the like another object that has that position that we gave it, so 0a. Actually, it might even be more sensical to look at y3. So y3 shows us the true dirtiness that goes on when we have multiple of them. So y3 is something tagged with a, and then another thing tagged with ab, and we see that we have 0a, 1b, so forth. In all cases, the values are unioned with undefined because they're optional. I'm not sure why that's important. So we see that for the kind of 0a, a, and then we also see that for the value of the top level object. When we have multiple of them, we're going to be omitting. So we have, this is I think I selected the block of the omit. So we're omitting type of key from that whole thing. And then we're still intersecting it with the second half. So that's how you get away with being able to tag regular types. Why in the world you would need to tag string or number doesn't make sense to me in the slightest, because I've seen this before with objects, but like, what would be the point? I don't know.
I mean, I've seen attempts to, or like the idea of like tagging a primitive value can be a way of like embedding information about maybe like the format of the value, which I haven't actually seen like work in a production context, but is an interesting idea to explore. So the idea might be like, you've got a string, and obviously it could be represented as the type string, but maybe you want to say this string actually represents an email address, and you have some validation logic that checks that this string is actually an email address, and then you're going to brand or tag it as an email address type. So it's not just a string, it's an email address. And then as long as you're doing those validations like on the boundaries of your system, so like where you're accepting an input from a user or maybe reading a value from a database, then inside your kind of like functional core, you have an email address type instead of just a string. But you can do that with like a very simple, just like intersection. You don't need the complexity that we're seeing here. So maybe there's another reason for this.
I've seen people do this kind of thing before, where it's like pn key of t p, and then they'll do like, I don't know, like I'm doing this wrong, but like and underscore tag, you know, I guess they would put K here.
Yeah. The one that I've seen, which is like, yeah, exactly. You can do something like this. Is even simpler, where you can just do something like this.
Yeah.
Right.
I didn't need to map it out. Okay. Yeah. Exactly. Yeah. And this is the tag thing. Yeah. So what's not clear to me is when it would matter. I don't know when it would matter that T, like why you would want to use this with a string, but I guess it may, like what you said, because if I make a function, so if I like type email string and I say like type, what would be another string type thing?
Phone number.
What'd you say?
A phone number, maybe?
Yeah, well, yep. I love that. Yeah, to all those listening out there, common programming mistake. Phone numbers are strings, not numbers. You would never add phone numbers together, right? Okay, so if I have like a function thing, and it takes in email, whatever, it does whatever. The problem is, are we on the same page?
Yeah, absolutely.
So like, the problem is you can pass anything in here.
Exactly.
And what we really want to be able to do is say, okay, let's try it. Actually, let's just try tag email. Wait, does that not work? Requires.
I think you'd want to tag a string with like the value email, and like email might be a tag.
Yeah. Okay. So let's try it. Tag string with email. Did I spell it right? E-M-A-I-L. Yeah. Okay. Mm-hmm. So in this case, it still works. Okay. So,
Well, so that's one of the interesting things though here, because like, for example, we can assign like x0 is equal to x1, right?
oh yeah,
So
yeah.
y0 is equal to y1. So this is different from like the way I usually see branding or tagging, which is that the untagged shape is still equal to the tagged shape, which to me, in my experience, seems to like negate the value of brands or tags. So yeah, I'm not clear on where this would be useful.
Yeah, if we
Yeah,
use
'cause
the
if you
version
do this-
that you were talking about and we do this, then we get our error.
Yes.
As you would expect. I mean, of course, the problem
Exactly.
is here, like this assumes you're never using underscore tag.
Yeah. Yeah, and you can like make that field whatever makes sense for your code base.
For once, I think I do have an answer to your question. Like, what would be the value? Let's leave this here in case we come back to it. The value here is x0 and y0 are not assignable to each other, nor are, so if we look at for y's here, x and y, like.
Well, but those are different base types though.
Right. Y1 and y2 are assignable to each other. How does that make any sense? Okay, never mind. I thought I had an epiphany, but I definitely don't. Okay, let's look at the tests. Maybe the tests will help us. We have unique symbol that we're using. So we're using this unique symbol thing just for these tests, I think. So if we tag null with foo, it's equal to null. If we tag null with undefined, it's equal to undefined. If we tag an object with x and the value 0 with foo, and then we intersect the keys of that object with string, it's equal to x. So we're doing that intersection to remove the symbol, I think.
Right.
Okay.
So we're taking the key of the tagged value, which is going to be like x and likely the tag, and then we intersect it with x to remove the tag.
So, okay, these are the helpers. Get tags is null, any, undefined they're all empty. So then we get an array back. We can tag unions. That's so crazy. We can tag a union of null and one with foo, and it still works. So that is something special, I think, right there. This is interesting. If we get tags, if we tag 0 with foo, and then we take that and union it with 1, we get nothing back. So this is like a weird edge case, I guess. I don't know. We're getting into like a weird universe here where I'm not sure why any of this would be done, but all the same. If we see that if we have a union of two things that are the same, so I think this would be, yeah, if we say foo, if we did that, would it work? No. Okay, well, I won't even try. We can, like you're saying, we can tag a string. We can tag never. Whoa. Okay.
So useful.
This is, yeah, so useful. Okay. All right. We can untag things. I think that kind of speaks for itself. We're just removing the symbol. We talked about that. We have we have hashtag here, which is just, we didn't talk about these. These are little helpers that were implemented. This one uses includes. Includes is a previous challenge. If you'd like to see how that works, go take a look. So we're doing hashtag, hashtags. So we have a single for hashtag. We have like the kind of plural version for looking at if it has tags at a path. I don't know. It just goes down the rabbit hole very quickly.
That's an interesting thing though, the has tag, because it's something that like our approach to like just more simple branding doesn't. I don't think you could really check to see. Well, I guess you could build up some types around that, but the interesting idea here is like, so let's say you have, like, to use our example of like an email address, you have a string, you could tag it as an email address. You can still treat it like a string because it compares. I mean, you can do that with brands also, but then you can also check later to see, does this have, like, did we tag this with the tag email address? And maybe do something with that. Yeah, I don't know. It's interesting that you can then like essentially query the tags that you've applied to an object while still being able to treat that object like an untagged, like it still is equal to its untagged type.
Okay, yeah, and I see what you mean. Yeah, like I think like 274 maybe is an interesting case of that. Like we tagged it with multiple things, and we can check whether or not it has. So I'm curious if the 274 will still pass if we just have foo. Yeah, it does. That's kind of cool. So we could tag it any number of times and then use this has tags type to say, hey, it was tagged with email. It was also tagged with personally identifiable information. It was tagged as like, some organization or whatever thing. We can tag it as much as we want. And then later we can just use has tags to get out whether or not it matches that. They're tagging big ints here on 278. Okay, very fun. Okay. And then, so that's what this one is, has exact tags. So this is if the other one was inclusive or, this is exclusive or. And so this one, this is exactly the same as the one I just did. It will fail. Yes. Okay, very nice. It will fail on 334 if we don't have exactly those tags. I don't think the order matters. Maybe it does, actually. Yeah, okay, the order matters because they're like, it's a kind of nesting. So that's an interesting...
that seems less useful.
It seems less useful all of a sudden knowing the order matters. So I would almost like to have... It would almost be better if has exact tags, you can pass in a union of possible tags, and it needs to have all of them.
Oh, what if you try like a tuple that is the union of foo and bar there?
Okay, that's not a bad idea. Like this? Nah. I think it's just the API is not built for that, but I would like to see an API like this where you can pass in any number of things and all of them must be present, but there's no order.
I guess that might work with like has tags where you could tag it with foo or bar and then use the union of foo and bar to check which one is there.
Yeah. So anyway,
cool.
Well, lots of head scratching to do on this one. I almost want to let's take my extension here out again. So you can't see this, Andrew, but let's see. I'm going to read it again and let's see if it makes more sense to us now, or read the top of it. Right. So now that we've seen all the code. So despite the structural typing system in TypeScript, it's sometimes convenient to mark some types with tags, and so that these tags do not interfere with the ability to assign values of these types to each other. For example, using tags, you can check that some value passes through the calls of a required function in the correct order. So you didn't ever get this. Let me copy this and let's go. I'll paste this so you can see it. I'm going to go to the top of the file here, and this is what they packed. Yep. This is what they gave us. Is true is the same as expect. Okay, so let's look here. Do a t extend string, so it's a generic t. Okay, returns the result as, and then we're tagging it with a. Okay, and the same thing for B, we're tagging with B. So the type of A is a tagged A and the type of B is a tagged B. So we're expecting the type of B. Oh, and then we tagged it again. So we're expecting the type of B to be AB. Okay. That's nice.
Interesting. This feels like maybe this is less about production types and almost like debug types, where you want to make sure that, I guess instead of just adding unnecessary keys to an object or something to see, to figure out what path it's taking or something like that, you can add these tags, which is why it's important that you can still compare it to, or it still can be treated like the untagged type that it is, in the example here, string. And you still need to be able to treat it as a string, but then you're essentially applying this metadata to it that you can then query to validate kind of whatever checks you want.
I think that's it. Yeah, I think you got it. I mean, there's more in the explanation here, but I think that's basically the point of this. And all of these other helper types are just to kind of make it more useful. So has tags, has tag, has exact tags, untag, all of these are just ways of interacting with all of this other stuff. But the point is that you could use this in the type system at the type layer to make sure that a value is passed in matches a certain thing. So this is basically a really weird workaround of things that other languages, in Go, for example, let's go to where did we delete it? No, we didn't delete it. So in Go, you could make, like, obviously this isn't Go, but like you can make this type email and it can be aliased to string, sort of. And you can make a function that takes an email and you cannot pass any other type to it. It's not structural. So you have to pass an email. And I guess that's kind of what tagging is there for, is to sort of help with that. This variant of tagging is something I have not seen before doing this challenge, but sounds like you neither. But definitely interesting stuff. So, well, Andrew, that's
it's interesting though that like type aliases have come up again here, because we were looking at that in the deep equals, right? And how you can like basically disable the structural comparison by like adding other stuff to your type. And now again, like we kind of come full circle with that. So I don't know. Maybe you want to cut that out because these are separate videos. Whatever.
Yeah. No, it's okay. It's okay. Yeah, it's. I think that was, you're talking about. Was it mutable keys or deep object to unique was the one you're talking about?
Yeah, exactly.
Yeah,
where we were like basically creating the same type is no longer the same shape. You can treat it as a different type.
Yep. Well, that's the extreme challenges for you. They're all a bit of a head scratcher. Just be glad that you didn't have to do the JSON.parse one with me, Andrew.
I've looked at that one, and this one seems easier somehow.
Okay, well, thank you so much for coming on.
Absolutely. Thanks so much.